Hi everyone, welcome to goclasses. So, in the last lecture, we were discussing GATE previous year questions of propositional logic. Part 1 we have already seen, many questions we have already done. Now, in this session, basically the remaining questions we are going to solve. So, this is GATE previous year questions part 2 for propositional logic. So, let's see our first question. The question number 1. Remember, this is part 2. So the part 1 you can find in the description or on the Go Classes YouTube channel. You can find the part 1 of this as you can see propositional logic GATE previous year questions part 1 you can find in the Go Classes YouTube channel, or you can find that in the description of this video. Okay, so now let's solve the remaining questions that we did not do in the last class. Now let's start with this question. So tell me what is the answer. This is a GATE 1996 question. The question is asking for not true. The question is asking for false statement. Which of the following statement is false? And four options are given to you, and the question is asking which of them is not true. Which of these implication is not true? See, in this question, implication is given to you. All these statements, if you notice, all the propositional logic formula, these are implication statement. Now, when can I say this implication is not correct? For example, tell me one thing, a simple question I am asking you. Can I say that if you are Indian, can I say this implication is true? If you are Indian, then you are, I can say, if you are Indian, then you are Rajasthani. Can I say? Can I say this implication is false or true? Tell me. I have given you one implication. You tell me one thing. Is this implication true or false? Can I say if you are Indian, then you are Rajasthani? The answer is no. So this implication is false. Correct? So remember, when can I say this implication is false? Because if you are Indian, that does not mean that you are Rajasthani. Correct? So very simple thing I'm telling you, that if you have any implication statement, I give you a implication statement, alpha implies beta. This statement I give you. Then this statement, when can I say this statement is false? This statement is false if it is possible to make it false. Okay, this implication, remember, this is an implication statement. When can I say this implication statement is false? This implication statement is false if it is possible to make it false. Okay, if it is possible to make it false, if it is possible to make, if it is possible to make it false. And when it is possible to make it false, when can I make it false? If you have this alpha implies beta, in which situation I can make this false? To make it false, remember, it should happen that in the this should be true, simultaneously this should be false. Correct? Simultaneously this should be false. So if this is possible, I can say, if it is possible, then I can say, remember, then this implication is false. Then this implication alpha implies beta, this implication is false. Is this clear to everyone? Please tell me, let me know. So the first order logic revision we will do after tomorrow. We will do the first order logic revision. This is propositional logic revision part 2. Okay, now, so tell me, is this understood? So very simple thing, that implication statement is given to you. Like, consider this implication statement. You can easily see this implication statement is false, because if you are Indian, it does not mean that you are Rajasthani. You may or may not be Rajasthani. Okay, so I can say it is possible to make it false. This implication statement, you can make it false. So easily I can say, if you have an implication statement, when can I say this implication statement is false? This implication is false if it is possible to make it false. And to make it false, whenever you have some implication statement, to make it false, remember, you have to make this LHS of implication true. Simultaneously, at the same time, you have to make the RHS of implication false. So if you can do this, then I can say this implication statement is false. I hope you understood the question. So in this question, 4 implication statements are given to you. You can see. Okay, and also one by implication statement is also given. So 4 implication and 1 by implication statement is given. Now let's see which of them is true. Which of them is not true. Which of these statements is not true? So let's check it out. Tell me the option A. Let's see the option A. That is, option A is X implies Y and X that implies Y. Okay, can I say that this implies Y? So you can see that this is modus ponens. This is actually correct. This statement is always true. This statement is always true means this is tautology. This a option A, this is tautology. Why this is tautology? This is a standard modus ponens. Correct. This, if you notice this argument, this is your modus ponens argument. The name of this argument is modus ponens. What this modus ponens argument says? It says that if x implies y and x is true, this is true, and x is true, then you can conclude, then you can conclude that y will be true. So this is a valid argument. This is called modus ponens argument, and this is a valid argument. So easily you can see that this option A, this is a tautology. So I can say that this is always true. Definitely this is not the answer because the question is asking for not true. So this is not the correct answer. Now let's see option B. What the option B is saying? Negation x implies y. Negation x implies negation y. Then I can say that it will be x. So let's see option B. What the option B is saying? Option B is saying negation x implies y and negation x implies negation y. Okay, negation x implies y and negation x implies negation y. Then what is the conclusion? Then the conclusion is x. Then the conclusion, your conclusion, that conclusion is x. So this statement is given to you. Now let's check it out. So tell me, is this statement true or false? This argument, is this valid or invalid argument? So you can see very easily that this is the statement, negation x implies y and negation x implies negation y, then x, then the conclusion is x. So is this valid argument? Let's check. So you can easily see that. Can you make it false? Can we make it false? Can we make it false? So let's see. If you want to make it false, then you have to make this conclusion false and all the premises true. This you have to make false and all of them you have to make them true. Okay, try to make them true. So let's check. So if I make this x false, then you can easily see this will be true, this will be true. Now you can see that if I make it false, if I make this y false, then this will be true. So I cannot make all the premises false, all the premises true. I cannot make this, not possible. This is not possible. So you can easily see this is a valid argument. So this option B, this is also a tautology, or you can say this is a valid argument. This argument is also valid. Okay, so this is very simple question. If you are not understanding this method, this argument method, if you are not understanding, then the same question you can solve directly also. Like the question is saying negation x implies y and negation x implies negation y. This complete expression implies x. This is your statement. Now again you can see this is an implication statement. Can you make it false? This is alpha, this is beta. You can notice if you want to make it false, then what you have to do? Then this is what you have to do. You have to make this alpha true. You have to make this beta false. Is it possible? Tell me, is it possible? A simple thing I am asking you, that you have to make alpha true, you have to make beta false. Is it possible? So if you make beta false, if you make this false, then it simply means that x is false. And if x is false, then you can see this will be true, then this will be true. Okay, so at this point of time, so this will be true, this will be true. And one thing you already know, we have seen this, that alpha implies beta. If this is true, then this whole thing will be beta. So basically true implies beta, that is same as beta. This we have already seen many times, multiple times we have seen this. So this is very useful. True implies beta, that is beta. So this true implies y, this is basically y. From here you will get y, and from here you will get negation y, and that will be false. So you can see that this is not possible. Is it possible? The answer is no. This is not possible. So you cannot make option B false. So this option B expression, if you notice, that is a tautology. You cannot make it false. Whatever you do, it is never possible to be made false. So clearly this is also not your answer, this option B. Now let's see option C. Can I say this is tautology? Can I say that this is always true? Can you make it false? This option C. This is saying that X implies, option C, if you notice, that is X implies X or Y. Can we make it false? Again, you can see this is a valid argument. This is a valid argument because if X is true, then automatically X or Y will be true. Okay, so this argument, if you notice, this is valid. This argument is valid. So clearly I can say that this is a tautology. This statement is tautology. You cannot make it false. Okay, this implication you cannot make it false. If you want to see, you can simplify this. So if you simplify this, we already know. Remember, alpha implies beta, that is equivalent to alpha negation or beta. So here, what you can do, you can simplify this. When you simplify this, this will be alpha, this will be X negation, or this will be X negation or X or Y. That will be your X negation or X. So you can clearly see this is a true. This is true. True or anything that is true. So ultimately I can say this option C is always true. Correct? This option C is always true. So this is you cannot make it false. This option B, this option C. So definitely this is also not your answer. So automatically I can say that answer definitely will be option D, but let's check it out. Answer will be option D, but let's check it out. Is this option D your answer? Let's see. X or Y, double implication, negation X implies negation Y. Okay, this is a double implication in the question. In the question he is saying that X or Y, this double implication, negation X implies negation Y. This is your statement. Please read the option D. This is option D. Now remember, this is a double implication, so this is by implication. Can you make it false? A simple thing I am asking, that can you make it false? This is the given. Can we make it false? Can you make it false? So it is easy. If you have alpha, double implication beta, when can I make it false? In which situation to make it false? What you have to do to make it false? Tell me. If you want to make it false, what you will have to do? You will have to make them different. Like either you have to do this alpha true, beta false. Either you have to do this, or you have to do alpha false, beta true. See, either you have to do this or you have to do this. One of them you have to do. Correct? Now let's see. Can we do one of them? Yes. First of all, you can simplify this. This X negation implies Y negation. If you simplify this, you will get, you can change it and you will get X or Y dash. So you can easily see it. You will get X or Y negation. This is what you will get. Now let's check. So you can easily say that, is it possible that you can make this truth value and this truth value different? Yes, I can do that, because what we can do, let's assume X is false, Y is false. Let's assume this. Now in this situation, this will be false, but this will be true, and false by implication true, that is basically false. So finally I can say this option D, this is not a tautology. This option D, this is not a tautology. So this is your answer. Your answer will be option D, because the question is asking which of them is not true. Okay, the question is basically asking which of these is not a tautology. Anyone has any doubt? Let me know. Ratul is asking, this GATE PYQ sessions, will they be for all the subjects? Yes, they will be for all the subjects. So currently operating system and discrete mathematics are going on. After this, we will take the remaining subject also. For the next, till the GATE exam, this GATE PYQ sessions will keep going on. Okay. Now, so you can just subscribe to the GoClasses YouTube channel, and you will every day you will get revision session of some subject. Like right now, operating system and discrete mathematics are going on. After that, we will take TOC, dbms, computer network, computer organization, operating system, all the subjects basically. So they will come. But before that, you tell me, is this clear? Is this clear to everyone? Let me know. Also, I want to tell you that don't see this video like a movie. Solve the question with me. Like I'm solving the question, you also solve the question. You take your copy pen and you have the question on your screen. I'm solving it, you can also solve it. Whatever I'm telling you, you can listen to that. If you have some doubt, you can ask. And so remember, this is a very nice question, because in this question, you can see 4 options are given to you. All these statements are implication or by implication statement, and you can easily see when can I say implication is false. Implication is false if it is possible to make it false. Okay, implication is false if it is possible to make it false. Like it is possible to make it false. If you are Indian, then you are Rajasthani, it is possible to make it false, because you may be Indian, this may be true, but you may not be Rajasthani. Maybe you are from Karnataka. So you can easily see that this statement, you can make it false, it is possible to make it false. So this implication is false. So remember, when can I say implication is false? When it is possible to make it false. Okay, or I can say implication is false when it is not a tautology. I hope this point is clear. Like in this option D, we are saying that can you make it false? Is there at least one situation where you can make it false? So you can see, yes, we can make it false. Option D is not a tautology. So this is your answer. So for this question, answer will be option D. Okay. If you have any doubt in this question, you can ask. Now let's move on. Let's consider this question. Solve this question with me. I am also solving, you also solve. So don't watch the video like a movie. Now let's see. This is GATE 1997 question on tautology. Some propositions are given to you, and the question is asking which of them is tautology. Tautology means always true. Means basically this tautology means always true. You can never make this expression false. These expressions, which of them is tautology, the question is asking. So let's check. It is very easy actually. This question is very easy. You tell me this option A. Just read the question. Intuitively you read, is this tautology? Intuitively you read, the statement is P implies Q. The statement is P or Q implies P. Very simple question I am asking. P or Q, does it imply P? If P or Q is true, if this is true, then can I say P will be true? If this is true, if this expression is true, if this LHS is true, can I say RHS will be true? This is definitely not tautology. This is definitely not tautology, because you can see that you can make it false, and at the same time you can make it true. All you have to do, just make P false and just make Q true. So you can easily see that this option A, this is not a tautology. Why this is not tautology? Because you can make this option A false. You can make this RHS, you can make false. At the same time, simultaneously, you can make LHS true. What all you have to do, just Q to P false, then definitely this option A, this expression will become false. So I can say this option A is not tautology. So what is this then? You can also make it true. So you can make it false, you can also make it true. Now, let's see this. So this is actually contingency. This option A, this is actually contingency. Why this is contingency? Because you can make it false in this situation. In this situation, option A will be false. And there is another situation where option A will be true. Like for example, if P is true. If this P is true, then definitely what will happen? This option A will be true. So I can say this is a contingency. You can make it true, you can make it false. Okay. There is at least one situation where this option A is true, and there is at least one situation where option A is false. So this is a contingency. This option A. I hope this is clear. Anyone has any doubt in this? So let's see the option B. What about option B? The option B is saying that P or Q implies P. This is the option B. P or Q implies P. So let's see, is this tautology? Can you make it false? Is this tautology? See, this is a very simple expression, so you can just simplify this. It will be P or, this will be Q dash or P. So finally it will be like P or Q dash or P. So that will be P or Q dash. Okay, so you can clearly see this is a tautology. Sorry, this is contingency, because you can make it false, you can make it true. So this is basically contingency. Why this is contingency? You can see that if P is true, then definitely this option B will be true. If P is true, then option B will be true. And you can see that if P is also false and Q is true, in this situation this option B will be false. So definitely I can say that both the situations are possible, B true, B false, both the situations are possible. So I can say this option B, this is a contingency. This is not a tautology. So this is not tautology, this is not tautology. Let's see the option C. What about option C? Option C is saying P or P implies Q. P or P implies Q. What about this? Is this tautology? Again, this is a simple expression. This is a small expression, so you can simplify this. So it will be P or P dash or Q. So you can see this will be true. True or anything, true or Q, that will be true. So definitely this option C, this is always true. You can never make it false. This option C, this is always true. So definitely this is a tautology. So this option C will be your answer. Let's see option D. P implies Q. So the option D is P implies Q. Can you make it false? Again, this is a small expression, so you can simplify this. There is no problem. Like if you simplify this, this will become P dash or, so this is Q. So if you simplify this, this will become P dash or Q. Correct? So it will become P dash or Q. So that will become P dash or Q ultimately. Okay. So that will become P dash or Q. Now again you can see this is contingency. This option C, this option D, this is contingency, because you can make it true, you can make it false. So option D, this is you can make it true in some situation, you can also make it false in some situation. So this is contingency. So your answer is going to be option C. So this is a simple question from GATE 1997. Option C is the answer. Okay, let's move on. If anyone has any doubt, you can ask. And please solve the questions with me. See, in these sessions, we are going to solve all the GATE exam questions. And what you can do, all these GATE exam questions you can solve in parallel with me. So there will be no waste of time. We are not going to waste any amount of time. Okay. Basically from the starting to the end, we will only solve the questions. You can consider that you are solving the question at your place and I am solving the same question at my place, and we are solving simultaneously. So you can consider this as a group study. Okay. So every question I am solving with the complete explanation. I am already giving you the complete explanation. I am already giving you the explanation of every option. Okay. So don't watch these videos like a movie. Try them yourself. So this is very easy. This is not these questions are not complicated. Now let's see this. This is GATE 1998 question. So tell me, the question is asking what is the converse of this statement. A statement is given to you. For this statement, what is the converse? First of all, you write this statement in the form of propositional logic. So what you can do, this I stay, let's assume this I stay, this is S. I stay, let's call it S. You go, let's call it G. Okay. I stay, I am calling it S. You go, I am calling it G. Now, this statement is like this: S only if G. This is the statement. S only if G. And we have already seen in our course that how to write this in the propositional logic. So we write it as S implication G. This is how we write. This we have already seen in our discrete mathematics course. The proof I have given to you. You don't have to remember this. The proof we have already seen. Because you can see S only if G. It means that without G, S cannot be true. It means if G is false, then S will be false. I can say if S is true, then G will be true. Okay. So you can easily see that this we have already seen. The proof I have already given to you in the discrete mathematics course. Complete discrete mathematics course is free for all the students on the GoClasses website. Just go to GoClasses website. You will find the complete discrete mathematics course, and that is free. You can watch it. Complete course you can watch it. So this is your S only if G. So in the propositional logic, you will write it as S implication G. This is how we write. So this, remember one thing. So we have already seen if I have A if B, how to write this? We write this as B implies A. Here B will imply A. But if you have A only if B, if you have this A only if B, how to write this? We write this as E A implies B. The reason is very simple, because this is only if. So without B, A cannot be true. It means that if B is false, then A will be false. It also means that if A is true, then B will be true. If A is true, then B will be true. And that is same as if A is true, then B will be true. Okay, so very simple. So this is how you can write this. Now let's move on. Now what is the converse of this? If I give you this statement, this is a conditional statement. For this conditional statement, what will be the converse? So there are three things. What will be the converse of this? For this, A implies B. For this, the converse will be B implies A. This is going to be the converse. There is something called inverse. Inverse will be negation A implies negation B. This statement will be inverse. And what will be the contrapositive? This statement will be contrapositive, that negation B implies negation A. Negation B implies negation A. This is a contrapositive. So these are the three things. The question is asking for converse. So what is going to be the converse? The converse will be, so you can see, the converse of S implies G. What is that? That is G implies S. So this is the converse. G implies S. So tell me which statement is correct. G implies S means if you go, then I stay. If you go, then I stay. If G, then S. So this will be like this. If G, then S. Or I can say S if G. Or I can say S if G. So it means I stay if you go. So the answer will be option A. This option A will be the answer. Okay. What about the remaining options? Tell me, what about the remaining options? So you remember the converse of S implies G, that will be G implies S. It means if G, then S. Or I can say S if G. So I stay if you go. So answer will be option B. What about this statement? This statement is simply if I stay, you go. That simply means S implies G. Okay. So what about this statement? If you do not go, then I do not stay. If you do not go means negation G implies negation S. Remember, this is equivalent to, this is contrapositive of S implies G. So this is contrapositive of S implies G. And similarly, if I do not stay, you go. What this means? If I do not stay, you go. So that means negation S implies G. So this is a simple question. Answer will be option A. I want to tell you one thing, that if you have any conditional statement, this is always equivalent to its contrapositive. The contrapositive negation Q and negation P. So this conditional statement, this is a conditional statement. This is equivalent to, this is called contrapositive. So for this statement, this is contrapositive. For this statement, this is your contrapositive. And so these are same. So similarly, you can notice for this statement, this is the contrapositive. The contrapositive will be negation P implies negation Q. So for this statement, the contrapositive is this. So these are same. So any conditional statement is equivalent to its contrapositive. This is a conditional statement. This is equivalent to its own contrapositive. Similarly, this is a conditional statement. This is equivalent to its own contrapositive. So every conditional statement is equivalent to its own contrapositive. So very simple. So here in this question, answer will be option A. These will not be the answer. Option B, C, D, these are not going to be the answer. Let's see this question. This is a GATE 1999 question. Please take your notebook. Please take your copy pen. Solve all the questions with me. I am solving, you also solve. Now let's see this. The question is saying that prove that the formula is not a tautology. You have to prove that it is not a tautology. So there are two questions. Another question is, if A is a tautology, B is any other formula, then prove that A or B is a tautology. So two questions we have to do. The first question is, prove that this is not a tautology on your screen. Negation P or Q implies P. So let's see the first part. The first part is negation P or Q. Negation P or Q implies P. Let's see, is this tautology or not? The question is asking prove that this is not tautology. So let's do this. Again, you can see that this is an implication statement. There are two ways to solve this question. Let me solve them. First of all, if this is not a tautology, can you make it false? This statement, can we make it false? Let's check. Can we make it false? So there is only one way to make it false. This is an implication statement. So let's call it LHS. Let's call it RHS. There is only one way to make it false. To make it false, there is only one way. What is that? If you want to make it false, there is only one way. What is that? The only way is that this LHS you have to make true and this RHS you have to make false. So this is the only way to make this implication false. So now you tell me how to make RHS false. This RHS, if I want to make it false, there is only one way. This RHS, if I want to make it false, then again there is only one way. Because this RHS is also implication statement. Look at this RHS. This is Q implies P. So this is also implication statement. Again, you can notice there is only one way. What is that? That only way is that you have to make this Q true and P false. This is what you have to do. P true, Q false. You have to do this. So finally, I can say that to make RHS false, this RHS, if you want to make it false, then only one way is there, and that is Q true, P false. This is the only way. There is no other way. This is the only way. Now, can you make LHS true? In this situation, try to make LHS true. This is the only way to make RHS false. Now, try to make this LHS true. Can I make this LHS true? You can see that Q is true, so automatically this LHS will be true. So this LHS is automatically true. So definitely, yes, you can make LHS true. So I can say this option A is not tautology because you can make it false. So this LHS is true. So finally, I can say this. Remember, LHS true, RHS false, LHS true, RHS false. It means this implication is false. So you can make this implication false. So you can make this expression false. This expression is not tautology. So can we make it false? The answer is yes. Yes, you can make it false. So this is not a tautology. So very simple. This is how you can solve. There is another method. Let me tell you. Another method is the case method. So you can create a case by case. You can do this same question. You can solve by case. This is very easy method. You can take two cases. Only two cases are possible because everything is a proposition. P is a proposition. Q is a proposition. So only two cases are possible. One case possible is P is true. Another case possible is Q is false. Sorry, P is true and P is false. Only these two cases are possible. Either this case will be possible or this case will be possible. No other case is possible because P is a proposition. So either it is true or it is false. So there are only two cases possible. Now in this case, when P is true, then you can see what this will become. When P is true, then this will become Q. Because P is true, so this will be false. False or Q, that will be Q. So it will be Q implies. When P is true, then this complete thing will be true. So this complete thing will be true. So Q implies true, that is your true. So you can see in this case 1, you got true. What about case 2? In case 2, P is false. So when P is false, then this will become true. Because P is false, so this will be true. True or Q, that will be true. So true implies. Because P is false, so it will be Q implies false. And what is alpha implies false? Whenever you have this. Whenever you have alpha implies false. What is that? Alpha implies false. That is alpha dash. Many times we have seen this also. You can check alpha implies false. You can write it alpha dash or false. What is alpha dash or false? That is alpha dash. So you can see this is going to be Q dash. True implies Q dash. What is that? That is your Q dash. So you can see that this is a contingency. Because you can make it true, you can make it false. This Q dash, this is, you can clearly see this is contingency. Either you can make it true or you can make it false. So this option A, this is contingency. On your screen, this is actually contingency. So it is not tautology, it is contingency. You can make it true, you can make it false. Now the same question also you can solve by the method 2, by the method 3, that is simplification. This method 3, this is simplification. So let's solve this question by the simplification method. You already know that if alpha implies beta, I can write it alpha dash or beta. This is what I can do. Now what I can do here, this is your implication. So I can write it p dash or q whole dash, whole negation, or q implies p. This q implies p, this is nothing but q dash or p. Now in this you can apply the De Morgan formula. The De Morgan formula, when you apply this, will be p q dash or p or q dash. Now in this you can apply the absorption formula. This is your absorption formula. We have already seen that alpha or alpha beta, that is your alpha. This is called absorption formula, absorption law. So you can apply this absorption law. This will be p. So finally you will get p or q dash, which is a contingency. This is nothing but a contingency. Okay, so these are the three methods to solve the same question. Ultimately this is not a tautology, so we have done this. The same question you can solve with many methods. Whatever method you like, you can try. The next is, the question is saying A is tautology, B is any formula, then prove that this is a tautology. A is tautology. This part, in this part, the A is a tautology. Tautology means always true. This is a tautology, it means always true. What about B? B is any formula. So A is a formula, B is a formula. So here, because these are formulas, so how many rows will be there in the truth table? Tell me, how many rows will be there in the truth table? This A is a formula, this B is a formula, this is formula, this is formula. How many rows will be there in the truth table? Can anyone tell me? Can you say the number of rows will be 4? Because you have two formula. Because you have two formulas, so can I say number of rows will be 4 in the truth table? Please tell me. Let me know. Can I say that? That number of rows will be 4? No, that is wrong. If you are creating 4 rows, if you are solving this question like this, see, if you are solving this question like this, if you are solving this question like this, that is wrong. If you are solving, it is possible that you can get the correct answer. It is possible you can get the correct answer, but this method is wrong. Why this method is wrong? Because these are formula, these are not propositional variable. These are not propositional variable. Many times we have seen this. Many questions we have done in our lectures, in our course. Many questions you have done in the test series, in the weekly quizzes. Still, many students, they are not clear in this difference. This is a very simple thing, that this A is a formula, this B is a formula. Okay, so there are some propositional variable. For example, there can be some propositional variable. So remember, their number of rows will depend on propositional variable. How many propositional variable are there? Not infinity. It depends on how many propositional variable they have. For example, if this B is a function of, PQR, and this A is a function of PQR, okay, this A contains PQR, this B contains PQR, then in that situation, you will have total 8 rows. In that situation, you are going to total have 8 rows. Is this clear? See, very simple. This A, this B, if this B contains 3, like if this B comma A, if these are containing 3 propositional variables, these are the variables, then I can say that there will be 8 rows. Anyway, so it does not matter. The point is that this A is tautology, means this A is always true. This is always true. Now, whatever B you have, you can easily see that whatever B you take, this A or B will always be true. Correct? So simple that now whatever B you take, it does not matter what B you take, whatever B you take, this A or B will always be true. this A or B, this will always be true. So that is the reason this is a tautology. Okay, so this is the proof. I hope this proof is clear, because let me tell you again. Remember this A comma B, these are propositions, or I can say these are propositional formulas. Because these are propositional formulas, so they contain some variables. They contain some variables. This A comma B, they contain some propositional variable. Let's assume they are containing some propositional variable like maybe P, Q, R, something like that. We don't know what are the propositional variable, but let's assume these are the propositional variables, something like that. Now, in this situation, number of rows will depend on how many variables you have. On that it will depend. We don't care, because our focus should be only on A comma B. A is tautology. A is tautology. Now, B can be anything. I don't care. I don't care. B can be anything. For example, B can be something like this. B can be contingency, tautology, contradiction. B can be anything. Now, you can easily see that A or B, that also will, or that always will be tautology. So that will always be true. This will always be true. So this is tautology. This is the proof. Let me know, did you understand this? Please tell me, did you understand this? This is GATE 2004 question. The following propositional statement, this statement is given to you. Is this satisfiable, valid, contradiction? What is this? So let's look at this statement. It is P implies Q or R. P implies Q or R. This complete expression implies, it implies P and Q implies R. It implies P and Q implies R. Okay. So this is the given statement. Now, what is the best way to solve this question? The question is asking, what is this? Satisfiable, valid, contradiction, contingency, all the things the question is asking. So what I can do, let's see, can you make it true? First you try to make it true. Can we make it true? Can we make this true? Let's call this formula number E. Can we make it true? Can we make this E true? If you want to make it true, all you have to do, just make it true. So yes, we can very easily make it true. All we have to do, just make R true. Just make R true. If you make this true, then this complete thing will be true. Please understand, if you make this R true, then this complete expression, this complete RHS will be true. Then you can see anything implies true will be true. So all you have to do, just R true. This R true implies E true. So if you make this R true, then automatically this E will be true. So which option is gone? Tell me. Please understand, the question is asking all the things the question is asking. Like the question is asking for satisfiability, validity, contradiction. The question is asking everything. So what I am doing, I am just seeing that, can I make this E true? Yes, I can make very easily. If I make this R true, then this will become true. Okay. And if this becomes true, then this implication will also become true. So ultimately I can say, if you make this R true, then E will be true. So which option is gone? Which option is gone? This option is definitely gone. Option C is definitely gone. Now let's see, can you make it false? This is your E. Can you make it false? Can we make it false? Now let's see. Remember this implication, if you want to make it false, what you have to do? Let's call it alpha. Let's call it beta. If you want to make it false, what you have to do? You have to make alpha true and you have to make beta false. How to make beta false? This is the beta. How to make this beta false? This beta is PQ implies R. Can you make it false? There is only one way to make it false. You have to make this false and you have to make this true. There is only one way to make this true. You have to make P true, you have to make Q true. Okay, now you tell me, can you make this alpha? What will be alpha now? Now this alpha will be what? This alpha will be, remember, P is already true, implies Q is true, R is false. So true implies true, that is true. So this alpha is true. So you can see that, can we make it false? Yes, of course we can make it false. We can make alpha true, beta false. It is possible. It is possible. So I can say this, can we make it false? Yes. Yes, we can make it false. So we can make it true? Yes. We can make it true, we can make it false. So ultimately this is not valid, this is satisfiable but not valid. We can make it true, we can make it false. So the answer will be option A. Okay, very easily you can do this question. Just see the option, and from the options you can understand that what this question is asking. This expression is given to you, this formula is given to you. The question is asking for validity, contradiction, satisfiability, everything the question is asking. So what we can do, let's see, can we make it true? Yes, we can make it true. If I make R true, then automatically this will become true. So definitely this is satisfiable, because you can make it true, so this is satisfiable. Now, can we make it false? Yes, of course we can make it false. We can make this false, we can make this true. So ultimately I can say this is satisfiable but not valid. Okay, this is statement, this is satisfiable but this is not valid. Is this understood to everyone? This question, is this clear to everyone? Please tell me. So very simple question, and you can solve like this. Of course you can solve this question using simplification also, but I think that will be time taking. That will take more time than this method. In this method, actually you don't even need to take copy pen. Without taking the pen, you can solve this question very easily. Just see, can you make it true, can you make it false? Yes, you can make it true. Yes, you can make it false. So definitely answer will be option A. So you can save a lot of time if you do basically if you solve the questions with the efficient methods. Now let's move on. Let's see this question. Let's see this one. The question is asking, this is a GATE 2005 question. PQR are three atomic propositional assertions. Tell me, are they variables or are they formula? Are they variables or are they formula? They are atomic. This PQR, they are atomic propositional assertions. It means they are variables. All of them are propositional variables. All of them, they are propositional, because propositional variable means atomic. These are atomic propositions. Okay. Now, X is this. This expression is X and this expression is Y. Which of the following is tautology? The question is asking relation between X comma Y. This is what the question is asking. So for this question, the best way is simplification. If you do the simplification, you can solve this question very easily. Okay. Now let's see what this X is. X is basically P or Q implies R. P or Q implies R. So what this X will be? This X will be negation of this or R. So that is going to be P dash, Q dash or R. Okay. So that this will be X. What is Y? Let's check. What is Y? So this is your X, because what you can do? You can just do the negation of this or this. So negation of P or Q, that will be P dash, Q dash or R. What is Y? Y is P implies R or Q implies R. This is Y. P implies R or Q implies R. P implies R, Q or Q implies R. So tell me, what about this one? So it will be like P dash or R. You can solve it. So it will be like P dash or R or Q dash or R. So ultimately this is going to be like P dash or Q dash or R. Now, what is the difference between these two? Let's see. X comma Y. You have this X. You have this Y. Let's see what you can say about these. So finally you have this X, that is P dash, Q dash or R. You have this Y, which is P dash or Q dash or R. Now tell me, does X imply Y? The question is, does X imply Y? Is this true? Is this tautology? Does X imply Y? Can I say is this tautology? If x is true, then can I say that this y will be true? Can you make x true, y false? Can you do that? Can I make x true? Can I do this? Can I do this, that this is true, this is false? Can I do this? Let's check, can I do this? If I want to do this, then definitely if I want to make it false, there is only one way. Remember, if there is only one way, if I want to make it false, there is only one way, that is r must be false, p must be true, q must be true. Now in this situation, okay, in this situation you can see that this x cannot be true, right? Yes or no? So this is, yes, definitely this is tautology, because you cannot make y false, x true. See, after making this, after this, it is not possible. This true, not possible. It is not possible. So definitely this x implies y is tautology. So x will imply y. There is no problem. There is no doubt. Is this understood to everyone what I am saying? Very simple. What I am doing, I want to see if x is true, then can I say y will be true? If I make it true, then can I guarantee that y will be true? So what I am doing, I want to make it true, I want to make it false. This is what I want to do. This I want to make true, this I want to make false. But you can notice, if I want to make it false, there is only one way. This is the only one way. Now in this way, this x will be false. This x will be false. So I cannot make it true. At the same time, I cannot make it false. So I can say x implies y, x implies y, that is correct. What about y implies x? What about y implies x? Can I do this? That I can make this true, I can make this false. Can I do this? Is it possible? Is it possible simultaneously? Simultaneously, is this possible? So let's see. If I want to make it false, r must be false, right? Definitely. Then r must be false. And you can see at least one of p comma q must be true. Okay, p or q must be true. This p or q, that must be true if I want to make it false. Now you can see that r is false. At least one of them is true. If both are true, then you can easily see that x will be, see, very simple. I am saying that take r false, take p true, take q true. Now you can see this will be false. This will be false, and you can see this will be true. So this is not tautology. So this is definitely not a tautology. So I can say x implies y is tautology, y implies x is not tautology. So which of them is tautology? The answer will be x implies y. This is tautology. Okay. So this is the tautology. Answer will be option B. Nothing else is the answer. Only this is the answer. Is this understood? Let me know. So simple question, you have x, you have y. These two expressions are given to you. And the question is asking which of them imply what? X imply y imply x. Okay, so what happens? That you have to decide. So very easily you can do this question. Here I can say x imply y will be tautology. If x is true, then y will be true. Okay, if but if y is true, then x may or may not be true. Okay, so if this x is true, then definitely y will be true. Definitely. But remember, it is possible that y is true, x is false. It is possible. So y does not imply x, but x implies y's. Okay, so automatically what will happen? This is also not tautology. Because remember, this x is equivalent to y if and only if this is tautology, this is tautology. These two are tautology. If and only if these two are tautology. Now let's see this question. GATE 2006. What about this one? The question is asking, these are the statements that are given to you, P1, P2, and the question is asking which is tautology. So let's see. What is the best way to solve this question? Like option A, can anyone tell me what is the best way to solve the option A? Option A is A and B implies C. This implies, this equivalent to A implies C and B implies C. What is the best way to solve this question? A implies C and B implies C. And in the other question, this is OR that is given to you. In the second question, here is the OR. In the second question, it is OR, it is OR. So can anyone tell me what is the best way to solve this question? The question is asking for equivalence. Are they equivalent? So let's call it alpha. Let's call it beta. Or you can call it, for example, maybe you can call it X. You can call it Y. You can call it Z. Now tell me, what is the best way to solve this question? You want to check, are they equivalent? So the best way is by case. This is the best method to solve this question, by case. You can solve this very easily by case. So what you are going to do? There are only two cases possible because these are propositional variables, or I can say these are propositions. Every proposition is either true or false. So for example, this, as you can see, this is your P1. So as you can see that it will be only two cases you can create. You can create with respect to C. The two cases you can create with respect to C. This is how you can create the two cases. C is a proposition, so either it will be true or it will be false. Only two cases are possible. There is no other case possible. Okay, so case 1, case 2. No other case is possible. Either this case will be possible or this case will be possible. Either C will be true or C will be false. There is no other possibility. Now, when C is true, then what is I? What is Y? When C is true, tell me. Anyone want to tell me? If this C is true, then what will be this Y? This Y will be true because anything imply true. Anything imply true, that will be true. Okay, this Y will be true. What about Z? If C is true, if this is true, then this will be true. If C is true, then this will be true. True and true, that will be true. So ultimately, I can say this will be true. So finally, I can say that in this case 1, you can see Y is equivalent to Z in the case 1. Correct? Case 1, in the case 1, they are equivalent. Now, in the case 1, if they are equivalent, can I say they are equivalent? In one case they are equivalent, can I say they are always equivalent? Tell me. In one case they are equivalent, this and this, they are equivalent. Can I say they are equivalent? No. You have to check for all the cases. If they are equivalent, they must be equivalent in all the cases. In every case, they must be equivalent. Now let's see when C is false. So when C is false, then what will be Y? If this is false, then Y will be negation of this one. Okay, because remember this, alpha implies false. That is nothing but alpha dash. Many times we have seen this. I told you this is very useful. This is very useful that alpha implies false. You can write it alpha dash or false, and that is same as alpha dash. So you can do that. Now, so finally here, if this C is false, then you can write it negation of A and B. Negation of A and B means A dash or B dash. This is your negation of A and B. Okay. Now let's see this. What will be Z? If this is C is false. If this is false, then this will be A dash. If this is false, then this will be B dash. Ultimately, this will be A dash and B dash. A dash and B dash. Are they equivalent? Are they equivalent? Tell me, are these two equivalent? No, they are not equivalent. So you can see that Y is not equivalent to Z. This Y, this is not equivalent to Z. So in this case too, you can see they are not equivalent. So definitely I can say this P1, they are not equivalent. Okay. So remember this A, the question is asking which of them is true. So remember they are not equivalent. So definitely P1 is not tautology. I can definitely say this P1, this is definitely not a tautology. This is definitely not always true, or I can say not tautology. Okay, what about the next? What about P2? This is your P2. The same method you can try by case method. There are only two cases possible. case 1, case 2, either C is true or C is false. Only two cases are possible. When this case, this is your case 2. Now you tell me, in this case what will happen? Again you can see this, you can call it Y, you can call it Z. So tell me what will be Y here. If C is true, then anything imply true. This C is true, anything implied true, that will be true. So this Y will be true and this Z will be true. So you can see in the case 1 they are equivalent. Y is equivalent to Z in the case 1, in this case 1. Okay, what about case 2? In case 2 what is happening? In case 2 C is false. So this, let's see this. Let's see what will be Y in this case. So because C is false, so it will be like C is false, so it will be negation of A or B. Negation of A or B means A dash and B dash. Okay, what will be Z? This C is false, so it will be A dash or B dash. It will be A dash or B dash. Again you can notice they are not equivalent. You can see they are not equivalent. So in this case 2 also they are not equivalent, these two. So definitely I can say P2 is also not tautology. So neither of them are tautology. Both are not tautology. So the answer will be option D. This option D will be the answer. Okay. So very easy question. You can do it like this. So can you see this case method is actually very good method. It will save you a lot of time. If you do the simplification, it will take a lot of time. Let me tell you. For this question, you do the simplification of P1, you do the simplification of P2, it is going to take a lot of time. You will have to simplify this, you will have to simplify this, simplify this, simplify this. For simplification, you will have to do. For this question, the simplification method will take a lot of time. Now think about it. If you do the simplification method, you are taking 2 minutes and some other student is doing the by case method and let's assume he is taking 30 seconds, 40 seconds. Then remember, saving time will help you. If you save time, definitely it will help you in the GATE exam. So like this you can do. So for this question, by case method is very beautiful method. Very easily you can do this question. And simplification method will take a lot of time. Let's see this question. This is GATE 2008 question. Now the question is saying that P, Q are two proposition. Which of the following are equivalent? Which of them are equivalent? Let's see. So option A, that is P or Q dash. What is option B? What I can say about this statement? This is the De Morgan law. You can apply the De Morgan law. So it will be like P or Q bar. So yes, they are equivalent. If you apply the De Morgan law, it will be P or Q bar. So definitely you can see that 1 is equivalent to 2. This first one, this is equivalent to the second one. Okay. Now, what about the next one? The next is saying that P and Q or P and Q or P and Q dash or P negation P and negation Q. See, let's solve this. Actually, what is option A? This option 1, 2. What are these? These are P or Q dash. So if you notice this P or Q dash, what this means? It means something like this. These are P or Q dash. It means that you have 0, 0, 0, 1, 1, 0, 1, 1. Then you can easily see that P or Q dash, it's like, it is similar to Q implies P. It is similar to your Q implies P. So it will be like, here you will have 0, everywhere 1. Now, what expression you can write? From this, you can write a SOP expression. You can write sum of product expression you can write from this. This sum of product we study in the digital logic. Maybe you have already seen this in the digital logic. You can write a sum of product expression. So what this expression will be? Very simple. Just focus on where it is true. Focus on where they are true. So you can notice they are true here. So I can say that it will be like P dash Q dash or P dash Q dash, or it is true here. That means P dash Q or it is true here. So that is P or Q dash, P and Q dash, or P and Q. So this is the statement. right? This is your SOP expression. Because remember, just focus where it is true. It is true here, it is true here, it is true here. This P or Q dash, this is true in this situation. So I can say this is true when both are false, or both are true, or P is true, Q is false. So finally, you will get this expression P dash Q dash, PQ dash, and you can notice PQ. So the answer will be PQ, P dash Q dash, and PQ dash. So definitely this third one is also same. This is also equivalent to P or Q dash. So I can say this is equivalent to the third one. Let's see the next one. This is saying P or P and Q, P and Q, P and Q dash. So this is not correct. So the answer will be this one. This is not correct. You can easily see that. For example, consider this situation where P is 0, Q is 1. In this situation, you can notice this option fourth. Option fourth will be what? When P is 0, Q is 1. P is 0, Q is 1. Then in this situation, this will be 1. But you can notice in this situation, this 1, second, third, they will be false. They will be 0. So you can definitely see that only 1, 2, 3, they are equivalent. The fourth is not equivalent. So these are equivalent. These are equivalent and they are not equivalent to fourth. So this is the answer. Okay, so this is also very easy question. Now let's see this one. Let's see this GATE 2009 question. So tell me the answer. Are you solving alongside with me? Please tell me. These are easy questions. Propositional logic is a easy topic, very easy topic. Are you solving these questions along with me? I am solving these questions. Are you also solving these questions? Please tell me. There is no need to watch the video like a movie. Always work it out. Always take your copy pen in with yourself. Do something on the copy. Write something. Whether you get the correct answer, whether you get the wrong answer, that does not matter. But you should try. You should attempt the questions. Propositional logic is very easy. I think in the GATE computer science, this propositional logic is the most easy topic. Okay, so I am solving these questions. You should also solve these questions. You can consider this like a group study with me. Okay, I can call these sessions as group study with me. I am solving every question completely. So you can see, for every question I am doing the complete analysis. In every question I am telling you everything. I am telling you what are the best method, what is the most efficient method, how can you save time, where you should take care, the analysis of every option, the analysis of option A, B, C, D for all the options. So all these things I am telling you. You try all these questions along with me. I am solving, you also solve, and you listen to me what I am telling you, where I am telling you to take care, where you should be aware. Now let's see this. This is your GATE 2009 question. The question is saying that there is a binary operation. A new binary operation has been defined. This binary operation has been defined. Now the question is asking what is this equivalent to. First of all, you tell me what is this operation. First you find out what is this binary operation. See this truth table. TT, TF, FT, FF. See, this is very similar to implication, right? Yes or no? This is similar to implication. This is similar to implication, but what is happening? This is false when this happens. So you can notice only in this situation it is false. So you can see this expression, this operation, this binary operation, it is false only when Q true, P false. So remember, this is false. When it is false if and only if P false, Q true. So this happens when this happens. Can anyone tell me when this happens? This happens when you have Q implies P. Yes or no? So I can say that this is actually nothing but your Q implies P. Can I say this is same as Q implies P? Agree? Because remember, when your P implies Q, this P implies Q is false when this will be false. This will be false if and only if P is true, Q is false. So only in this one situation, only in this situation it will be false. Similarly, this Q implies P. When can I say this will be false? This will be false if and only if Q is true, P is false. Only in this situation it will be false. Now you can see here, Q is true, P is false. In this situation it is false. In all the other situation it is true, true, true. So I can say finally that this P, this Q, this is implication or backward implication. Please tell me. This is implication or backward implication. So I can say this is backward implication. Right? This is a backward implication. What it means? It means this is a backward implication. Please understand, this is backward implication. Okay, now this is very easy. Now the question becomes very easy. Now the question is asking, okay, what about this one? What this will be? Remember, this is backward implication. Please understand, this is your backward implication. So you know that this is equivalent to contrapositive. This expression is equivalent to contrapositive. So it is like P bar implies Q bar. That is equivalent to contrapositive, means Q implies P. Okay. So I can say yes, this is definitely correct. Option A is definitely correct. What about option B? What about this option B? Remember, this is a backward implication. So that is same as Q dash implies P. And that is same as P implies Q. P dash implies Q. So that is same as P. Remember? Yeah. Sorry for that. What I'm saying. The question is asking for P or Q. So this option A, that is your Q dash or P. So this is not correct. Because this option A, this is Q dash or P. The question is asking P or Q. So option A is Q dash or P. Let's see the option B. What this option B is. Let's see this one. So here you can see this is backward implication. I can write it Q or P. Yes, this is correct. So this option B, this is correct. What about option C? What about this option C? This option C is same as negation P. So that is same as your Q dash or P dash. That is Q dash or P dash. So definitely this is also not correct. What about this one? What about this one? This option D. So let's look at option D. Option D is this box Q dash. So remember, this is backward implication. This is your backward implication, and that is same as Q or P dash. So definitely this is also not correct. I can say option D is also not correct. Answer will be option B. Okay, option B is going to be the answer. Very simple question, but this is a nice question. What is the mistake many students do? The mistake they will do is they will consider this as forward implication. Okay, this is a common mistake in this question. The common mistake will be something like this, that this is the, and if you write it as P implies Q, this is a wrong. Okay, this will be wrong. This is the mistake that will be very common mistake in this question. This is going to be very common mistake. So don't make this mistake. You can solve the question very easily. Now let's see this question. Tell me the answer. The question is 2014 question. Which of the following propositional logic formula is true when exactly two of them are true? When exactly two of them are true. Okay, exactly two of them are true. Now these are the options. Some options are given to you. Some biconditional is given to you. Some biconditional is given to you. Some options are given to you and biconditional is given to you. Let's see. What we want? We want exactly two to be true. Please understand. We want this statement that exactly two of PQ are true. Exactly two of them. Exactly two of them must be true. So how to write it? If you solve this question with a simplification method, If you simplify option A, option B, option C, option D, then that is gone. Just think about it. If you solve option A, if you simplify option A, simplify option B, simplify option C, simplify option D, how much time it will take? How much time it will take? It will take a lot of time. Okay, it is going to take a lot of time. So definitely it will waste a lot of time. This is a MCQ question. You can solve this question very easily with analysis. Analysis can you can do the analysis of this question. You can see that options have some by implication. In all the options you have some implication by implication. You can check it out. Every option has implication by implication. So you can do the analysis of this question. You want exactly two of them to be true. Now you can see that what I can do. Remember, please understand, there is some by implication. So I will focus on this by implication. P comma Q, P comma Q. There is by implication with P comma Q. For this P comma Q, there is some by implication for this. Okay, for this one, there is some by implication. So what I can do, I can write it like this. There are two cases. When exactly two of them are true, then this would be true. So you can notice, if R is true, if R is false, then P comma Q must be true, right? So either this should happen, or what should happen? Tell me. Either this should happen, or what should happen? Tell me. If R is true, then what should happen? Now, exactly one of them must be true. Do you agree? Do you agree that either this should happen. R is false, then P comma Q must be true. This is the R is false. Here you can notice. When R is false. When R is true, then what should happen? Then this should happen that this must be true. P XOR Q must be true, right? Do you agree? Do you agree? Because this means exactly one of them. This means exactly one of P comma Q is true. Exactly one of P comma Q is true. Okay, let me know. Is this analysis understood? Please tell me. What I'm telling you, is this understood? So this is what I'm telling you. See, either R will be false or R will be true. Only two cases are possible. Either R will be true. Either R will be false. If R is false, then P comma Q must be true. Okay. If R is true, then exactly one of P comma Q must be true. Exactly one of P comma Q must be true. Agree? Because R is already true. So exactly one of P comma Q must be true. How can I write this? How can I write? This I can write as P XOR Q. I can write this as P XOR Q. This I can write as negation of P by implication Q. Correct? I can write this as negation of P by implication true. So remember, very simple. Either I can write this as like this, that this P XOR Q must be true. Okay, this must be true. Or I can see this must be true. Negation of P by implication, this must be true. So finally I can say either this and this same thing. This same thing I can write in another way. I can write like this: negation of P by implication Q, that must be true. Okay, so that's it. Now you can easily see what this will give you. P is true and Q is true and R is false. Or R is true and negation of P by conditional Q. Okay, this is true. This is your answer. That's it. Is this analysis understood to everyone? Please tell me. See, if you solve this question by simplification, simplify option A, option B, option C, option D, that will take a lot of time. It will waste a lot of time. Is this analysis understood? We want, see, you can easily see that P comma Q, there is by implication. With P comma Q, they are using implication by implication, something they are using with P comma Q. So you can get this idea. This idea you can get this. These two you have to treat together. So this idea you can get. So you can create two cases, either R is false or R is true. These two cases you can create. If R is false, then they must be true. P comma Q must be true. If R is true, then exactly one of them must be true. So from this idea, I can say that either this should happen, means P is true and Q is true and R is false, or this should happen that R is true and this is a true. So from this you can check it out. The answer is going to be you can see the answer is going to be option B. Option B will be the answer. Is this understood to everyone? Please tell me. Is this understood? So answer B, answer will be option B. Okay. Now let's move on. So very easily you can do. See, the same question you can do by case method. You can also solve this question by case method. You can create cases on for example R. You can create two cases. But this analysis is also very easy. Very easily you can do this analysis. I hope you understood this analysis. Please tell me. Did you understand this? Please let me know. Let me know, did you understand this? Okay, let's move on. Now let's see this question. The question is GATE 2014, question number 53. Which of the following Boolean expression is not a tautology? Which of them is not a tautology? So some options are given to you. Now let's see. First of all, let's see option A. What option A is saying? Is this tautology? You tell me. This option A is saying that A implies B. Okay, A implies B. This is what option A is. A implies B. And B implies C. And B implies C. A implies B. And B implies C. This whole thing implies A implies C. The whole thing implies A implies C. Yes, this is valid. Yes or no? This is the valid argument. This is a valid argument. What is the name of this argument? Anyone? This is a valid argument that A implies B, B implies C, so A will imply C. This is a valid argument and the name is transitivity of implication. This is the transitivity of implication. Implication is transitive. So this is your transitivity of implication, or you can call it hypothetical syllogism. This is the name, hypothetical syllogism, or you can say transitivity of implication. So this is a valid argument. Because this is a valid argument, so this is tautology, like A implies B and B implies C. If this happens, then A will imply C. So this is tautology. This complete expression is a tautology. So very easily you can do. So this is a tautology. Definitely the question is asking not a tautology, so this is not an answer, because the question is asking which is not a tautology. Let's see the option B. Option B is A implies C. Let's see option B. That is A implies C implies negation B implies A and C. So what this question is saying, that A implies C. This implies this one. This implies negation B implies A implies C. A and C. Okay. So for this question, you can do the simplification actually. For this question, let's do the simplification, or you can do by case or something you can do. Okay. Many methods you can try. So we want to check whether this is tautology or not. You can try this method. What you can do? Can you make it false? Can we make it false? Tell me. Can we make it false? Tell me. Like, let me assume this is Y. Let me assume this is Z. Can we make it false? Like, is it possible that Y is true, Z is false? Is it true? Is this possible? Is it possible? Tell me. Is it possible? Can you make y false, y true, z false? See, if you want to make z false, then what you will have to do? If you want to make it false, then what you will have to do? Definitely, definitely you have to make this true and you have to make this false. So it means that B will be false and AC will be false. B will be false and AC will be false. Okay. Now, can you make Y true? Can I make Y true? Yes, of course I can make Y true. What I can do? I can take, for example, I can take A equal to false, C equal to true. I can take this. So can I make Y true? Yes, Y true possible. Okay. After making Z false, Y true possible. So this is possible. Yes, this is possible. Is it clear to everyone? Yes, this is possible, right? See, you can make it false. You simultaneously at the same time you can make it true. Okay, this is false, this is true, at the same time you can do this. If you want to make it false, then B dash must be true, this must be true, this must be false. So I can say B must be false and this AC must be false. Now you can see I can make Y true. Definitely I can make Y true. This Y true is possible. All you have to do, just take A false, C true. This is what you can do. Very simple. So finally I can say, yeah, this is not a tautology. So this B, this is definitely not a tautology. So this is your answer, option C. Let's see option C. That is ABC imply C or A. Tell me, if A, B, C are true, if they are true, then can I say A or C will be true? Just a simple question. Intuitively you tell me what your intuition tells you. If you know this is true, A is true and B is true and C is true, if all of them are true, then can I say this will be true? Tell me. A true, B true, C true. If all of them are true, then can I say this will be true? Yes, of course this will be true. So definitely this is I can say this is a valid argument, or I can say this is a tautology. So definitely this is valid. Okay, or I can say that A and B and C, if all of them will happen, then definitely this will happen. So this is a tautology. Okay, so very simple. Finally, your answer will be that this is tautology. So this is not your answer. What about this? What about this option? So can I say A implies negation B or A? Can I say this? Can I say this? If A is true, then negation B or A will be true? Can I say this? Can I say this? That if this is true, if you make this is true, then can I say this will be true? Can you guarantee this will be true? Yes, of course, this will be true. Correct? This will be true. So this is also tautology. So option A, A, C, D, these are tautology. So the answer for this question will be option B. That will be the answer. So very easily you can do these questions. Let's try this one. This is your GATE 2014 question. Tell me the answer. GATE 2014. Two statements are given to you. Good mobiles are cheap. This P, what this P is saying? This P is saying that good mobiles are not cheap. So it simply means that this P is saying that if mobile good, okay, if mobile good, then it is not cheap. Correct? This is what statement P is saying. Yes or no? Statement P is saying that good mobiles are not cheap. They are not cheap. These good mobile phones, they are not cheap. It means that if mobile is good, then definitely it is not cheap. So this P, what you can say, it will be like good mobile phone implies not cheap. Okay, good mobile phone implies not cheap. Now what is this Q? This Q is saying cheap mobile phones are not good. If it is cheap mobile, then it is not good. Okay, if mobile is cheap, it is not good. From these two, you can easily see that they are contrapositive of each other. Correct? Agree? They are contrapositive of each other. They are contrapositive of each other. You can see that this P is good mobile phones are not cheap. What is the contrapositive? The contrapositive, what that will be? That will be Q. Cheap mobile phones are not good. You already know that if this and this, they are contrapositive of each other, then they will be equivalent. Definitely they will be equivalent. So you can notice P is equivalent to Q. Okay, P is equivalent to Q, and that means P implies Q and Q implies P. They are equivalent to each other. They are equivalent. So it means P will imply Q and Q will imply P. So finally your answer will be P imply Q, Q imply P. They are equivalent to each other. So all of them are true. The answer will be option D.